Okay, today we're going to be talking about describing the transformation given an original function and then a new function. But before we do, there are a couple of new transformations that we need to discuss. So we've talked about vertical and horizontal transformation. There is two more transformations, basically just one, but different variations of it, that we still need to talk about, and those are reflections across the x and the y axis. Okay, so when we're talking about reflecting across the x and the y axis, basically, um, if we make our function negative, so if we did the function notation thing, if there's a negative f of x, this is going to be a transformation across the x-axis. So vertical trans or reflection, sorry. It's going to be a vertical reflection. It's going to reflect across the x-axis. So it would flip it upside down, basically. Okay, so if I'll give you an example here in a second of what a vertical or a reflection across the x-axis is. And then the other type of reflection you might encounter is when, whoops, the input is turned negative. Okay, and this basically, it's hard to see, but I made that a negative x instead of just x. So this would flip it across the y-axis, or basically a horizontal reflection, would flip it that way. Okay, so for example, if I had just the function 4 to the x power, if I did a transformation across the x-axis, or flipping it upside down, the new equation would be negative 4 to the x power. So the negative would go to the base. Okay. If I reflected it across the y-axis or horizontally, it would become, so this is x-axis, x reflection. And then if I just made the x negative, that would reflect across the y-axis, so y reflection. Okay, and I'll go into that in a little bit more in the next assignment, but we're going to start encountering some of those reflections in this section today, so I thought we should talk about them now. So those are the last two transformations you have to worry about. So adding outside the parentheses, vertical goes up and down. Add, you go up, subtract, you go down. If you are adding or subtracting inside the parentheses, adding would go to the left, subtracting would go to the right. If you are making the whole function negative, it's going to flip it across the x-axis. If you're just making the input negative, it's going to reflect it across the y-axis. Okay. So let's talk about the transformations. And all we're doing is describing. So basically, we're just doing the verbal description. Okay, that's all we're doing today. But we're not doing the function notation or anything like that. We're just given two equations, and we have to figure out what changed between them. Okay, so the first equation is our original equation. So f of x started out as 3x minus 13. Okay, then we get a new equation that has been transformed. So this is like when we rewrote it right here. This g of x would be like what we did right here. That would be that new equation. Okay, so now we have to come up with basically what happened. What did we do to get to this new equation? So what's 3x minus 13? You notice we have this parentheses here, right where the x was. So instead of just 3 times x, it's 3 times x plus 4. So that means there is a horizontal transformation, right? And when we add in the parentheses, that means we're actually going to the left. So that means we added 4. That means we went left 4. Okay, then it's minus 10. Is that different from minus 13? Yeah, it's 3 technically more, right, than negative 13, because we went 3 in the positive direction, which means we would have had to add 3. So this is where we get confused when we're dealing with negatives. But yeah, because 10 is technically a smaller number than 13, right? But negative 10 is a bigger number than negative 13, which means we added 3, which means we went up 3 spots. Okay, and that's all we need to do in the sections. Just again describe what changed between our two equations. So over here in this one, we have 3 to the x plus 1 as our original, and then it became 3 to the x plus 4 minus 10. So again, we look at it, what changed? So it was 3 to the x plus 1, it became 3 to the x plus 4. Difference between 1 and 4 is 3, and it went up, so that means you added 3. And when you add to the input, to the x, that means you are going to the left. So this one went left 3. Okay, and then there was nothing after the exponent before. Now there's a minus 10, so that means they subtracted 10 outside the parenthesis, which means it was a vertical subtract. You go down that many, so down 10. Okay, then let's look at our other linear here. We have 2 to the x plus 1, and that became 2 times x minus 9, and then minus 3. So 2x became 2x minus 9, which means we are subtracting 9 to our input, which means it's a horizontal transformation. When you subtract, you're actually going to go to the right that many. So I'm going to go right 9. And then plus 1 became negative 3. This is where I see a lot of mistakes. So many students will put down 3 on this one. But the problem is that it was at plus 1. What would I have to do to plus 1 to get to minus 3? By minus 3 from plus 1, I'm going to be a negative 2. So that means I had to actually subtract 4. So that means I went down 4 spots. So make sure you're looking carefully at these and double checking your answers when you've written down stuff. Okay, last one was 4 to the x minus 1, and it became 4 to the negative x minus 1. So the only thing that changed is my x became negative. So again, this is going to be one of my reflections, right? Because all that I did, the only input, if I put it in function notation, would be f of negative x. So I just changed the x to a negative, and if I do that, it's going to be a y reflection, right? It's going to flip it left to right. Okay, it's going to reflect across that y-axis. So this is a y reflection, and that's it. Nothing more to it than that. Oops, can you zero out? There you go, y reflection.